Welcome to 8.2, Solving Systems of Linear Equations by Substitution. The substitution method relies on the following fact. The solution to a system of linear equations is the point at which the graphs of the two lines intersect. Another way to say this is the solution is where the two lines share an xy point. Just an important note, I may refer to the point of intersection as the POI. So here's our first example. At the top of your screen, you're going to see two equations. The first is 2x plus 3y equals 2, and the second equation is 3x plus y equals 10. We're going to solve these two equations together by using the substitution method. Our first step is to solve either equation for x or y. Basically, we want to isolate one of the variables. Equation 2 seems a little easier to deal with, so we're going to use that one. So I'm going to take the first equation, 3x plus y equals 10. I'm going to subtract 3x from both sides to isolate the y. So I will get y equals negative 3x plus 10. One important note, try and look for a variable that has a leading coefficient of 1, like the y in the second equation. If you do this, it makes your job a little bit easier when you're trying to isolate for the variable. For step 2, you want to substitute the equation from step 1 into the equation you have not used. So for us, that's equation 1. So I'm going to take my first equation, 2x plus 3y equals 2, and we know that y equals negative 3x plus 10, and I'm going to plug or substitute negative 3x plus 10 in for y. In doing so, I'm going to get this equation below. 2x plus 3, in parentheses, negative 3x plus 10 equals 2. For step 3, I am then going to take that equation and I'm going to solve. So to solve this equation, I'm going to distribute the 3 to get 2x minus 9x plus 30 equals 2. I will then combine my like terms to get negative 7x plus 30 equals 2. I will subtract 30 from both sides to get negative 7x equals negative 28, and I will then divide both sides by negative 7 to give me a final answer of x equals 4. Once you've solved for one of the variables, you want to substitute that variable back in to either of the original equations to get the value of the other variable. I'm going to use the second equation, 3x plus y equals 10, and I'm going to substitute the x equals 4 into that equation. So I will get 3 times 4 plus y equals 10. I will simplify that to get 12 plus y equals 10. And after subtracting 12 from both sides, I will get y equals negative 2. Just an important note, I always like to use the equation I did not use in step 3. For example 1 continued, we now have a point of intersection, which is 4, negative 2. For step 5, you should check your answer into both of the equations. So if I substitute 4, negative 2 into the first equation, I will get 8 minus 6 equals 2, and I do agree that 2 equals 2. I will then check this solution into the second equation, and I will get 12 minus 2, and I do agree that 2 equals 2. For example 2, we have two equations up at the top again. The first equation is x minus 4y equals negative 3. And the second equation is 2x plus 6y equals 15. Step 1, we're going to solve either equation for x and y, which means to isolate the variable. For this example, I decided to use equation 1. Seems a little bit easier. So the first equation is x minus 4y equals negative 3. I'm going to add 4y to both sides to give me x equals 4y minus 3. And again, that important note, try and look for a variable with a leading coefficient of 1. For step 2, you want to substitute that equation from step 1 into the equation you have not used. So for us, we're going to use the second equation. So I have 2x plus 6y equals 15. I'm going to substitute 4y minus 3 in place of x. For step 3, I'm simply going to solve the equation. And my first step is going to be to distribute the 2. So I will have 8y minus 6 plus 6y equals 15. I will then add like terms to get 14y minus 6 equals 15. I will add 6 to both sides to get 14y equals 21. And finally, I will divide by 14 to give me a final answer of y equals 1.5 or 3/2. Once we have this answer, we're going to substitute that back in to one of the equations. So for step 4, we're going to substitute this into either of the original equations to get the value of the other variable. I chose to use the first equation, which is x minus 4y equals negative 3. And in place of y, I'm going to put the 1.5. So I get x minus 6 equals negative 3. And by adding 6 to both sides, I get a final answer of x equals 3. And just a note again, I do like to always use the equation that I have not used in step 3. So since in step 3 I used the second equation, for step 4 I decided to use the first equation. It's easier this way, and in case you make a mistake in step 3, if you use the equation that you haven't used in step 3, you're less likely to make mistakes. For continuation, we now have the point of intersection at 3, 1.5, and we're going to substitute that into both of our equations. So for equation 1, we substitute 3 in for x, 1.5 in for y, and when we reduce and simplify, we end up getting negative 3 equals negative 3, which is a true statement. We will do the same for the second equation. We will substitute 3 in for x, 1.5 in for y, and we happen to get another true statement that 15 equals 15. So therefore, 3, 1.5 is the solution or point of intersection of the system of our equations. For example 3, we have two equations at the top of the screen. The first equation is 3x plus 5y equals 10, and the second equation is 4x plus 2y equals 11. For step 1, again, we're going to solve either equation for x or y. However, neither equation seems easier to deal with. I don't see a variable x or y that has a 1 in front of it. So I'm just going to pick an equation, and I just picked equation 2 to start with. So we're going to start with 4x plus 2y equals 11. I'm going to subtract 4x from both sides. I'm then going to divide by 2. And this will give me an answer of y equals negative 2x plus 5.5. Feel free to use fractions, so you could have this at 11 divided by 2, or decimals, which would be 5.5. For step 2, you're going to substitute this into the equation that we have not used. In our case, that would be our first equation. So I'm going to replace the y with negative 2x plus 5.5. Once we have that for step 3, we're going to solve this equation. So I have 3x plus 5, and then in parentheses, negative 2x plus 5.5 equals 10. I'm going to distribute the 5, so that'll give me 3x minus 10x plus 27.5 equals 10. I will then combine my like terms to get negative 7x plus 27.5 equals 10. I will subtract 27.5 from both sides, which will give me negative 7x equals negative 17.5. And I will then divide both sides by negative 7. This will leave me with x equals 2.5. I do suggest that if you're going to do fractions as your answer, then make sure that both answers are fractions. And if you're going to do decimals as your answer, make sure both answers are in decimal form. We don't really like to see one of each, So keep that in mind. So since I used a decimal for x, I'm going to make sure I'm using decimals throughout. So for step 4, we're then going to substitute this 2.5 in to either equation to get the value of the other variable. So I'm going to use equation 2, 4x plus 2y equals 11. I will replace the x with 2.5. I will then simplify to get 10 plus 2y equals 11. I will subtract 10 from both sides to get 2y equals 1. And after dividing by 2, I will get an answer of 0.5. To continue our example, our point of intersection is now 2.5, 0.5. I will substitute this into both equations. So for equation 1, I will substitute 2.5 in for x, 0.5 in for y. And after substituting, I will get 7.5 plus 2.5, which equals 10. So I do agree that 10 equals 10. I will then check the solution into equation 2 by replacing x with 2.5 and y with 0.5. I will get 10 plus 1 equals 11, and I do agree that 11 equals 11. So 2.5, 0.5 is the solution or point of intersection of our system of equations. There are two special cases that may occur, and the first one is parallel lines. So for parallel lines, I have two equations up here. The first one is 2x plus y equals 8, and the second equation is 4x plus 2y equals 11. If we try and solve this, step 1, I'm going to take the first equation and I'm going to isolate the variable. So when I isolate the y, I get negative 2x plus 8. I'm then going to replace that into the second equation to get 4x plus 2, in parentheses, negative 2x plus 8 equals 11. Now when I go to simplify for step 3 and try and solve, I'm going to end up with a 4x minus 4x plus 16 equals 11. When I reduce this further, I get a statement that says 16 equals 11. So my variables canceled, and I end up with a false statement. So just remember that if we get a false statement, we did learn this back in Unit 1, and we said when this happens, our answer is no solution. So just remember we're trying to find a point where these two lines intersect. So if you get a false statement, that means that these lines will never intersect. So that means that these lines must be parallel. A second case that may occur is same line. So our first equation is going to be 6x plus 2y equals 10, and our second equation is 3x plus y equals 5. When we go to solve this one, and I'm going to take the second equation this time, which is 3x plus y equals 5, I'm going to isolate for y to get y equals negative 3x plus 5. When I substitute that in for step 2 into the first equation, I get 6x plus 2, in parentheses, negative 3x plus 5 equals 15. Again, when I go to simplify, I end up with the 6x minus 6x. So my variables cancel, but I end up with 10 equals 10. And I actually agree with this statement. This is a true statement. So if you get a true statement, again, back in Unit 1, we said when this happens, our answer is called an identity or all real numbers. So remember, we're trying to find a point where these two lines intersect. If you get a true statement, well, that means that these lines intersect everywhere. So the two lines must be the same line. Just to recap those special cases, if you get a false statement, the answer is parallel lines. And if you get a true statement, the answer is same line. This will conclude our 8.2 notes. So please prepare yourself for next class by making sure you have all your notes completed. And I would even take a look at the questions from 8.2 to make sure that you know what's going to be asked of you.